I'm a little bit hoarse, but that's, I think, more talking too much this weekend than anything else. Okay, and with that, let's get started. The title, of course, is a Hemingway reference for the two of you that are old enough to have been required to read that. So, for this talk, it's good to know what the target audience is. I'm going to assume that you are already a programmer, but since you're probably younger than me, you probably learned in a considerably more newer and more dynamic language than C. So that means I assume you know how to program. I don't have to tell you that. I assume that you think that all documentation was always on Google, and books are for sissies, so you can Google for all of the basic syntax things you want. That means I don't have to do that for you. I'm going to give you so what I'm going to do is try to leverage the skills you already have in an unfamiliar environment. Okay? So let's get started here. The first thing we're going to try to do, we have three things to do. The first one is your design skills probably have some object-oriented component because most of the recent languages are object-oriented. C is not an object-oriented language, but that doesn't mean we can't make it do things. So let's begin here. Here's the short version of how you do this. Turns out that a file in C is basically a module. So all of you Python programmers should rejoice, because that's exactly how Python works. We just don't get it namespaced for us. However, that means that we also can use the semantics of modules to represent classes. All right? The other thing we can do is we have to have a place to put instance data. We can represent objects with a struct. For you Python programmers, essentially think of a named tuple. It's the similar idea, just much faster. All right? Our classes, then, are not going to be dynamic objects. So I'm sorry to tell you, Ruby programmers, we are not going to create new classes at runtime and then monkey patch them from, head to hell and back. What's happening is that they're going to be a model like C++ or Java. The other thing I want to tell you is this is not a condescension. This is actually my preferred C style. The graybeards may do it in a more procedural way, but this is as good as any method you can use. It's also, by the way, the style of the POSIX thread library. It's not exactly obscure. It's just not usually taught from the beginning, but it will help you. So first of all, let's talk about what I am and am not going to do. We have three parts to the traditional definition of object-oriented programming. The nice thing is the parts that have the biggest win are at the top, as is the parts that are the easiest to do in C. So in the time we have, we're just going to do encapsulation, and I'm just going to mention the others a couple of times. Okay. We're going to do this by way of example, and what we're going to do is we're going to build a trivial little logger. It's primarily an excuse just to demonstrate the features you would want from a class, okay? And since the C constructs don't say anything about classes or objects, this is where Google would fail you without a little direction. All right, first thing we need, C files, if you don't know, C code is always broken up into .h and .c files. The way we're going to think of this is .h is the public interface you're going to export. .c is the private implementation and anything else that you want to keep private. In the .h file, the first thing we need is a place to put our instance data. These are our objects. We are going to, all I'm doing here is, this is an odd little declaration, but it's actually two things. And so this green thing surrounds the middle. And the middle thing is actually what we need. We're going to make a struct, and to get the semantics of the reference-based semantics, I don't need to define it here. So I'm just going to declare it here. However, C has this missed feature that certain things go in a tags namespace, which most of us these days I think is a bad idea. So I've declared a struct, I've given it a name, which I'll explain, but I'm surrounding it with this type def, and all I'm doing is I'm saying I don't want a type struct, so I want you to alias it into the default namespace. So don't get confused by the type def. Okay? Now, anything else I want to say here? No. All right. Excuse me? Yes. The reason is because I could have given a different alias, okay? So I'm saying that in the default namespace, this name is an alias for this name in the tags namespace, Okay? So it's confusing and simple and confusing at the same time. But yes, that's why I wanted to explain that, because it wouldn't be obvious. All right. So, why did I give it this crazy name? C does not have namespaces. Namespaces are a good thing. A lot of the things in your language are there because we discovered we needed them in C back in the 70s and 80s. So the way you hack in namespaces is you use prefixing, which works fine, except you don't get to abbreviate anything. So what I've done is I've said I have a project-wide namespace, which I'm calling DLL, because that's my initials. Probably won't collide with anybody. And I've done something very un-C-like, with all the graybeards in the room are angry with me, because I actually wrote the class name in camel case. I will explain that. You actually really need class prefixes in this style, because classes typically have, you have 100 classes that have a set and a get and a length or a size or something, and we have to disambiguate them. In an object-oriented language, the class itself would give you a namespace, so that's what I'm doing. If you look at how I do this, right, when I define other things, then this will be create inside the class namespace. However, the project namespace might be irrelevant, because the fact that the C community doesn't use camel case means I can use it to always indicate this thing has object semantics, not C's basic procedural semantics, and no one else is using it, so I have a free namespace. You don't have to do that. The other thing is that if you're doing procedural code, you'll really need a project namespace. I'm going to show it, but you might be able to drop it, because you're probably not going to collide if you use your classes. Okay, I have to define this thing. It gets defined in the .c file. Remember struct and then the name? Same thing, except now I'm giving it a definition. It actually only has one instance variable. And I'm sorry to tell you, this is going to hurt you more than anything else. We have no native string class. So what this really is a pointer to a bag of characters. Yes, it's a pain, but that's the way it is in C. Okay, I don't have to type def it. We already have an alias made. Okay, and again, the name is the name of the class. All right. So now here's the thing. We have objects now. What we need is a way to actually create them. Since I don't need to put these on the stack, because we said we're going to have the same reference semantics that Python and Java and Ruby all use, then I'm just going to create a factory function, because it's a nice way. So this is now, the way to read this thing is in the DLL project, there is a class logger, which has a create method. Okay? That's how all of these get read. And, of course, I have to pass in the category, meaning I want the logger to say category, colon, and message, right? So I'm going to save the category. Each logger will know its own category. So is there anything else I want to say here? Usually I say these things and then I look to see if I didn't natter on about them. Not a big deal here. If you actually want things to sit on the stack, which is actually a really good idea, I just didn't want to explain it, pthreads will show you how to initialize things. Or you can ask me afterwards. Now, I'm not going to read all of this. What I want to show you mostly, this is the implementation, right? And the reason that I didn't put there's a little too many lines here for me to show you, like the prototype. This is the entire body of the function. I just want to point out a couple of things, because I don't want to get in the weeds with this. C does not know about objects, so therefore I can't say, give me an object. What I can do is say, give me a bag of bytes, which is what malloc does. But I have to tell it how many bytes, and that's machine dependent. But the size of operator will tell me how many I need to store an object. So all I'm saying is, please give me a chunk of raw memory that is big enough to hold one of my objects. And then this is about making sure that I actually was able to get the data. And I'm not going to point out anything else except for two things. Number one, this is, see the arrow here instead of a dot? It's because this is a pointer, but this is how we're going to access our instance variables. It's very much like saying self dot in Python. So that's not too unreasonable. Also, because I'm calling this function, we own a new copy of this category string, and we're going to have to delete it, but we'll do that in our destructor. All right, welcome to manual allocation. All right. Now, we've got objects. Yes? Oh, this one, I'm sorry. Where did I say that? Okay. What's up? Okay, I'm going to run out of time if you read very many of them. Normally, I will just automatically say whatever is on their stream of consciousness because that's what those things are, the things I want to say. Okay, I have an object. Now I can even make them, but I need to do something. I need an instance method. So what am I going to do? Well, this is going to return nothing. Void is how you spell don't return anything in C. Void star means something utterly different. Welcome to the insanity of C overloading names. This says I'm going to return nothing. Later we'll talk about returning error codes, but for right now we're not doing that. Notice in the DLL project I have a logger class that has an MSG method. So again, it's consistent. Of course, I name it self because that's what it is, and you Python people will be happy. The C++ people probably want to call it this. Don't do that. I always want my C to compile correctly as C++, and if you step on C++'s reserved words, it won't work for for no good reason at all. So self is always first, just like you're used to. And again, you'll notice because I'm taking a pointer that is a reference to self, we have the semantics I promised you. All right, how do I implement it? Well, a couple of things. It is just what you'd expect. I have to reproduce the signature, but a couple of things. This really doesn't have to be done this way. This is an excuse to show you the remaining things, the remaining pieces that you expect from a class. This thing is actually a class variable, so it's shared among all the instances of this class. This is a private instance method. This is a private class method. Honestly, they're only that way instead of inline, so I can show them to you, and I'm not going to show you everything, but let's take a look at how would we define this class method. We do two things. Number one, this goes right where a Python programmer thinks it should. It's just defined at file scope at the top of the .c file, just what you would do in Python. The only weird things are I have this little m prefix. Why do I do that? It's actually optional. I just like to know what things are module scope. Okay, so I do that. You don't have to do that, or if you think it should say class, use a C. The other thing is we do not put this, or we do not declare this in the .h file because why? Because we don't want it visible at compile time to anybody else. It's private to us. The weird thing is I have this static keyword. What that means is that means that the linker doesn't allow anyone to see it either. Okay, so this is how you do private class data. You could also initialize this. I didn't because I wanted to show you an init function. So if you look at the code, you'll have a class function to initialize the class. Two warnings for Pythonistas. You might be very tempted to make the name in all caps because Pythonistas love to make module level things in all caps. Do not do that. There is one of the most important conventions in C is that all caps means a preprocessor symbol. You need to know that or you will be sad, and so you never step on that with anything. The other thing is you probably kind of want to make private things have a leading underscore. The problem is that puts you into a namespace that the compiler has the right to stick private implementation stuff in. Probably you'll get away with it, but I just wouldn't ever use a leading underscore for anything. All right, so I'm only going to say a couple of quick things because at this point I think you know enough to read the entire file. This being a private method, I have to say static. That works on functions as well as it does on data. And the only other thing to point out is I didn't prefix it. Why not? Well, I could, but since this is all local to the module, as long as it compiles for me, it'll work for everybody because nobody else is ever going to see it. So you might not have to, and that was the point I was trying to make. I might not have to namespace this, and then it's, that's a kind of a choice of yours, but generally speaking, since it's private, as long as it doesn't actually, you will not mess up anyone else's code. All right, so how does this look when you actually use it? Okay, so, well, all right, so this is now in demo logger.c. Basically, the usage is, okay, I need a reference to a logger, so I have to call the create method. I give it the category name main. Then I need to send a message, right? So I send this log message, and then I destroy it, okay? So I didn't show you the implementation, but I have a destructor because I have memory to free. The ampersand, some people would not do that. The reason I pass in a reference to this pointer is so I can null it automatically. Since that's the best practice in C, it's nice to have one thing I can automate in C. Okay, what happens when you run this? Just type make, you run it, what do you get? You get this. Nothing startling, but the point is our objects work just like we like, except for the fact that you were desperately wanting to type log.msg of the string. That's the part we're not going to get, because you can make C do a lot of things, but you cannot make it give you syntactic sugar, except maybe with the preprocessor, and that has consequences. So we're not doing it. All right. So I think everything else in the file is obvious. I think you'll be able to read it just fine, because I've given you just enough hints to where to look that I think it'll all make sense. I'm going to very briefly say something about what happens if you want the rest of object-oriented programming. Okay? Here's the thing. The golden rule is less is more. You can get more, but it will cost you more, and so you only do the things you really, really need. Okay? So, first of all, a lot of times people want inheritance to inherit implementation. That's actually a bad idea. That turns out to have been one of the worst ideas about the way people did object-oriented programming. Best practice nowadays, usually people say, own an object, use composition. That already works. So you can reduce your desire to have inheritance by doing the right thing and just having your objects own other objects to use their services. You also will never get ad hoc polymorphism, meaning function overloading. You can't force C to do that without writing your own preprocessor, and at that point, write your own version, write your own compiler. It's not worth it. C also, it doesn't fit C. C intends to be explicit, no magic, well, except for integer conversions. No magic, so don't try to give it to it. That part will not work. You can get parametric polymorphism, meaning, I can substitute one object for another and pass because they have the same interface. You can do that. It's considerably more work. I leave that up to you. That can be worth doing in large projects. You could get implementation inheritance, but don't do that. That's already been done for you, and it's called C++. And it's not worth you trying to do it. About less is more. Oftentimes, the best thing to do is to pick one thing that fits your design. And that might just be that your objects know how to destroy themselves and nothing else. You can hack that in pretty easily, and you can get quite far by picking the one thing you need for your design. Because in C, you're doing it by hand. Only do things that really give you a return on investment. All right, so that's quasi-object orientation. Let's do the second thing that you wouldn't ever have had to have done in a modern language, which is manual memory management. And thanks to Sun's genius marketing juggernaut back in the 80s or so, everyone now thinks this is impossible, even though freshmen learned to do it when I was young and we walked uphill both ways. So I'm going to tell you the most useful thing I ever figured out about this from many years of listening to people argue and not understanding why nothing made sense. Memory management is a design issue in disguise. And if you understand that, you have one of the two big things that I want to help, the two big ideas I want to help you with. Turns out that there's a proof that I could tell you in about 3 minutes that a perfect garbage collector has to solve an undecidable problem. It's equivalent to the halting problem, and what that means is there are none, there won't be any, because that's not a thing computers can do. So even in your language, you do not have perfect collection, and without knowing it, you make designs that restrict yourself to the programs that you can actually collect. What's that look like here? Very quickly. So here's a Venn diagram. The universal set is general programs. What that means is every possible string that your interpreter or compiler will accept. Now, we can't do anything with these things. In particular, we can't collect them. In fact, that's a special case of something called Rice's theorem, which is the end of our hopes and dreams, really, because Rice's theorem says that you can't actually know any non-trivial feature about a general purpose program because they're all undecidable questions, everything you'd ever want to know. So in reality, you don't write those. Even in your collected language, it can't be done. What you do is you write what I'm calling a subset. I'm calling it collectible because I don't know. I've never seen a standard name for these things. What you're actually doing is you make designs that allow you to restrict to situations where liveness is equivalent to reachability. What do I mean by that? So all of you Java or Python programmers, suppose I have a giant data structure. Maybe I had to use it on some sort of complicated startup, and I'm done with it. That means it's dead code because it will never be a dead memory. It will never be looked at again. But I still retain a pointer to it. Tell me, what will happen to that structure? It'll hang around forever. Why? Because you have dead code that is reachable, and your collector doesn't know anything. It's undecidable to know if it's dead, but it knows it's still reachable. So what do? You null the pointer, don't you? You set it to nothing, null, none, whatever your language says, and that means now you have made it so that that being dead is the same as being unreachable, and then your collector understands. So even in with the best collector in the world, it actually still has a manual component, and so you make sure that you design your programs so that you don't have so that you can identify the dead code and you don't leave dangling pointers. It's a design problem. It's not obvious, but it really is. So I'm not talking about this because I'll run out of time. I define this little set I call manageable, and I mean precisely something that I'm going to explain called, these are programs for which you can identify sole ownership for memory. My point is that the only difference here is that you're going to have to design to a smaller subset of general programs. All right, what is that set? Well, let me explain what it means for a pointer to be an owner and or a borrower. So this is about any reference to a chunk of memory. Owners have some privileges. First of all, they're allowed to loan the reference out to a borrower. You will see what I mean completely concretely. Now, if he hasn't done this, if there are no outstanding loans, that means that there's no other copy, basically, of that reference but the owning pointer, you're also allowed to transfer, ownership to another owner, and then it doesn't belong to you anymore, and you're not responsible. But what you must do, once you have transferred it, you can't reference that pointer. You don't have a lease. You do not have a borrow on it. And furthermore, if you still own a piece of memory, before you go out of scope, you have to free that memory. The only things you can do with memory are free them or pass the buck to somebody else. Okay? The other thing is that you do have to make sure that when you loan to borrowers, you only loan to borrowers who will relinquish their loan before you have to either transfer ownership or free it. Okay? Borrowers have rules too. Of course, they can freely access borrowed memory as long as they have their loan is good, and they can even grant subleases. In other words, what this really means is they can call a function themselves. But borrowers never free memory, ever. Okay? They also can't pass the memory on to an owner because they have no ownership to transfer, and they have to guarantee that any subleases they make expire before their own lease does. Now, what in the world is the point of these rules? It's actually something quite profound. What it means is that understanding when to free memory, instead of being a global property of the program. How many people love implicit, emergent global properties of programs? Okay? I would be worried if anybody said yes, but the point is that memory handling is no longer that. Now, every memory handling decision is local and evident in the lexical scope, okay? That's provable, I believe. You always know when memory should be freed, okay? That means, number one, it's actually simpler to write functions in general by obeying this discipline. It also means that it's easy to do other best practices like nulling pointers after you either free them or you transfer the ownership, so that if you make a mistake, it crashes and tells you instead of running on in a state you don't understand. A question you might ask, Well, if that's the case, why doesn't, Doug, the graybeard Unix programmer in the next cubicle, why doesn't he do this? Okay? Well, the fact is, it's a pretty good chance that if you tried, he's doing something very like it, even if he doesn't describe it that way. I kind of realized I did it implicitly, but no one had ever taught me. That's why I'm making this explicit for you, because there's no point in beating people with a stick until they somehow absorb by osmosis things that could be explained. It also leads to higher quality code, because if you know what you need to do explicitly, you can reason about it. Okay? Now, let's give an example here. So there is a demo ownership file, and in that I'll show you a snippet. Here it runs a couple of tests. I'm only going to show you one, but what am I doing here? Okay, now notice this weird little prefix. But since I already made loggers for the previous topic, we're just going to use loggers. Okay, so that's the resource that we need to manage. So I'm going to create one. This one's going to have the category demo 2. And the reason it's like this is because I also had a different, there's a different pointer, but I have this funny prefix. What is that prefix? Anybody guess? That means it's an owning pointer. Why am I doing that? C is not going to help us with this notion, folks, but it's nice to have a little bit of lexical help in reading it. I am declaring to the reader my intent. I am making a contract with the next programmer that reads it that I will obey the ownership rules with this pointer, right? Okay? And I'd better keep that. If there is no prefix, so it's just like you'd normally write a pointer, I am making a contract that I will obey the borrower rules. If I apply this consistently over the code base, it's surprising how much clearer things are. So what did I do here? Well, I'm going to pass this to a function, and the name tells you what it's doing. I'm actually transferring ownership to this function. I don't own it anymore. I'm not allowed to touch it. So what I should do is null the pointer so I don't have something that points to things I'm not allowed to touch, right? Okay, so that's pretty easy. But notice that I know this is correct just by looking at the scope, because it couldn't be anything else, and the entire program is correct as long as this guy meets his contract. Local. That is the theme here. Okay. So what about this new owner function? It looks about the same because he's taking ownership. So ownership's being passed in, so I give it this prefix. He's going to loan it to a borrower. So what that means is he still owns it, which means when he comes here, he is an owner. And so he's going to call new owner, he's going to call new owner, he's going to transfer it once again down the stack. Okay, now he doesn't own it. So the only thing he can do is, well, nothing, but he should null the pointer just to declare that he doesn't own it, and so that somebody else doesn't someday edit this and put down below there some, misguided reference to it. Okay, so we've satisfied our contract. It's evident lexically that we've satisfied our contract. Okay, so what does the borrower do? He doesn't have a prefix on his parameter because he is only borrowing, right? So that means that we know that he's done the right thing here. I did something here that I won't press you to do, but I kind of thought it was interesting that I can make it absolutely explicit that I know I'm a borrower and I'm satisfying the contract. In this case, it doesn't matter because I'm about to fall off the end of the function. But if this were the first few lines in a function that's this long, it would be worth doing that, wouldn't it? If I'm done with it, it's nice to just say, hey, I'm done. But you don't have to do that. Okay. Now let's look at new owner. Okay, so again, there's my ownership prefix. So pass it to a borrower, fine, same guy. But he didn't transfer ownership. So he is responsible for fulfilling his contract. He will fulfill it by rather than passing it along. Now, same thing. Every one of those things can be, they're correct by local inspection, and the correctness composes so that you know that as far as that entire call goes, it's correct because it's correct locally. So what does it look when you run this? I'm sorry this is a little smaller, but there was too many lines of output. what has happened, I use the colors to show you which function is reporting what it's doing. So main, the main function, what does he do? Transfers ownership to a new owner. Okay? New owner loans it to the borrower, who's in green. What does he do? He uses the log, which is actually, basically this. And then he nulls his reference. Again, you didn't have to do that, but it's nice to be explicit, right? Okay, now we're back in new owner, who still owns the pointer because he just loaned it. Now he's going to transfer it to new owner, who's in red. He's going to loan it again. Same borrower borrows it, does the same thing. Now we're back to new owner. He fulfills his contract by destroying it. Yes?
Did you show the implementation? I thought the destroy function there was...
I did not show the implementation largely because I'm afraid I'm going to run out of time. So...
If I got that right, then technically the destroy function is now the owner and then actually runs free.
Technically, yes. We usually don't think of it that way, but you're right. When I write it, I know I'm taking ownership because otherwise I could not call free, right? So exactly so. Okay, so he fulfills it by destroying it. Notice the last two lines of output. I'm not using the logger. Why am I not using the logger? Because I don't own it, right? I mean, well, it's gone, but I don't know if I know that. I mean, maybe he did something crazy with it. The point is I'm not allowed to touch it. I have no lease. So I just called printf directly. I thought it was kind of nice that it showed what was happening there. Okay. Now, here's a tool. If you start playing with C and you don't know what this tool is, say hello to your new best friend. Okay? Valgrind, if you run it, it does some wicked magic, and then it runs it and knows everything you did with memory. Okay? So when I run it, it'll produce some output, and it says all heap blocks were freed, no leaks are possible. The point is, yes, we handled memory correctly simply by following those rules and simply by reasoning locally, not globally. And that's really the point that I want to emphasize. Okay? Congratulations. You now have the mental tools to be better than half the C programmers out there. In fact, I'm ashamed to tell you that it's probably a lot more than half because there are an awful lot of people that write tremendously bad C code. I don't want to point at any fields, but electrical engineering and science. I have a degree in science, so not bad in 15 minutes, right? Okay, third thing that I think is worth talking about, and that is, what do you do when you have exceptions except you don't have exceptions, right? Okay, so what I mean by exceptions, there are exceptional conditions, and then there are language constructs designed to help you with them. We do not have those constructs, so we have to handle them by hand because we still have exceptional conditions, right? So what we're going to do is we're going to do this systematically, and that's the point. Most of us all learn to do this ad hoc. So first of all, there's only one way to do this, and that's to use error return codes. I'm sorry. I know it sounds, tedious, but easy. The problem is that it isn't really that easy if you think hard about it, but it is still tedious. We apologize. Here's actually, okay, so I have to stop the talk now because it's time for a commercial from our sponsor. The public service announcement of the day is never imitate libc's interface. Pretty much never. I mean, a stop clock is right twice a day. But every possible stupid interface mistake has probably been put in libc, and there are what? I mean, 100 billion might be conservative. 100 billion. The point is that the entire world depends somewhere on these little bits of C code, whether it's DNS. I mean, so we're stuck with it forever. But don't do stuff just because libc does it, okay? So what we want to do is do it right, and we want to do it consistently. So I'm going to start naming some patterns because I've never seen them given names, and so I don't know that they have a standard name. So I am going to just fearlessly give them names, and thus they shall be forevermore. Let's talk about the C exception reporting pattern. Okay? Any function that can fail and needs to be able to report that, we always report the error code with the return value. So that means we're not returning results from the return value unless there was no error possible. We actually return results with reference parameters, basically without parameters. In other words, you pass in a pointer and say, put the answer here. Okay, why do we do that? Sometimes it's annoying, but it has a certain advantage, which I will explain. The other thing is our error codes always use negative logic. This is just instinctive to a C programmer. If you think about it, so 0 is falsy in C, okay? There's only one number that tests false, and there's only one way to succeed, which is to succeed. So that one is the one we use. There are many, 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 many ways to fail, and that's fine because we have many, 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 many non-zero integers. So naturally, what we are reporting is whether there's an error, not whether there's a success, right? Okay. Usually we end up making a set of global error codes for a program. So here are the ones in error.h that I am using just for purposes of the demo code. And this illustrates a few things. So first of all, see how this is again surrounded with typedef? Okay, so don't be deceived by that part. I'm just putting it in the default namespace so I don't have to say enum and name all the time. Okay. So I want the success code to be 0. Now, the truth is it would be 0 anyway, because if I don't set it to something else, this is the default. I like it explicit. Okay? You don't have to do that, but I like it nice and explicit. And then, for purposes of this program, I have cases where I simulate an allocation failure, I simulate an error during computation, and actually there are some cases where I might have a real allocation error, so I gave it a separate code. I like to have a guard value, so this is not a valid error, but if you want to loop through the codes or you want to see if a code is valid, it's really nice to have the last one be something that shouldn't ever occur. Isn't that nice? And it also then counts how many there are. All right, so how do I use this? Well, I need a reporting interface. And this is the reporting interface which I more or less described. I'm going to return the code. So that's the return value. This actually is exactly how I define a certain thing in the demo error.c. So I'm going to pass in a place to put the result. And it has to be 2 pointers because I want someone to be able to modify a pointer that I have. Welcome to C and double indirection. We apologize again. And then I have some arguments that just have to do with with getting that resource. So that's really all there is to it. I want to explain now. Now is a good time to explain why I insist it's the return value, by the way. If you think about it, there is a certain property which I want to have the ability to do, even though it makes programming a little harder. But if you really want to write reliable code, you would like to say that on an error, there will be no state change in the program. The problem is that a return value always has to come back. So I'm going to change someone's state if I return something. Whereas if it is a reference parameter, I simply don't touch the pointer, right? So that's one reason it has the right semantics. On the other hand, we always have to return an error code, even if it's only, hey, there was no error. So the return value has the right semantics for that. But the most important reason is that the return value allows me to simulate a try-catch block in a language that has no try-catch blocks, okay? So let's look at a try-catch pattern here. So somewhere at the top of the routine, I create an error code value because I'll do this in most of them. So here I have, I've shortened this up a little bit. It's not exactly what's in the file, but it's morally equivalent. So here I have a pointer. Notice since we've already gone past the ownership part, I'm using the ownership prefix. Now I do something that will bother some of you. I just warn you in advance. I'm actually assigning in the if test. So why am I doing that? Well, I'm doing that because for a real try-catch pattern, I need to do this equivalent to accept class as like E in Python, meaning I need the actual error to be visible in the block. So I want to both test its value and I want to assign to it. This is idiomatic in C, but most compilers know that people have beat their heads against the wall for generations by mistyping single equals when they meant doubles. So most compilers will complain. GCC has this very bizarre but very useful feature that, so first of all, unlike Python, you must have parens around it because that's actually grammatically part of the statement, not part of the expression. In GCC, if you put 2 of them, it will not give you the warning about a single equals. It's weird, but you know what? It's rather handy. I don't think there's any equivalent in Visual C. So in Visual C, you'll do what your programming teacher wanted anyway, which is to simply do the assignment first and then just go if error. That's fine, especially if you belong to the religion that says you shouldn't assign up here, but you will see this because this is idiomatic C. And here's my catch block, okay? So Now I want to talk about that one other feature that I'm asking for. The hardest thing to do in any language that doesn't have, that's not a pure functional language is manage state. And when errors occur, I really need to still know what the state of the program is to recover. And the only way to do that reliably and composably is to have absolutely no change when there's an error. So I actually want to give my programs commit or rollback semantics. I want to have them be transactional, and this pattern makes that easy. Okay, so with that in mind, I can tell you the complete pattern for how all the little jigsaw pieces fit together, okay? And I call it the C exception handling pattern. So anything that could receive an exception or report a exception, which is almost everything in most projects, I follow the same outline. I acquire all the resources I will need at the beginning of the function. I'll do the work in the middle, but I will store the results in temporary variables, okay? Once I know that no errors are possible, I'm guaranteed to succeed, I will then point, remember the out parameters that I'm passing them in the parameter list. I will then modify the pointers they gave me to do that to point at the results because I'm committing. I know that the transaction succeeded, now I commit, and then of course I have to release the resources in reverse order. So it's a little bit of a pain, yes?
Did you say that you changed the pointer so you're not going through the pointer that was passed in to change the value that's stored there? You're actually changing the pointer?
Well, remember, I passed in a pointer to a pointer. And because I passed in a pointer to a pointer, I can change the pointer. Welcome to C and double indirection. We apologize in advance. In C, we don't give you any help. We assume you can implement it yourself with the low-level tools. That's an example. So because I took a double pointer, then I can modify the single pointer you passed in, right? If it was an int, you would pass me a pointer to an int, and I would modify that one. This is just you're passing me in an int or a char pointer. No, I'm doing star equals. Star equals. I'm saying the value that this thing points to is going to change. Okay? That's something that you'll have to think a little bit about and Google. I'm trying to make sure that you know it's there, but I probably...
Can you say how it would work for if it were an int instead of a pointer?
Okay, so if I want to, if I'm returning an int, my parameter would be int star, would be a pointer to int, and then when I'm ready to commit, let's say the int is a, okay, so int star a, then when I'm ready to commit, I would say star a equals the value. And star means put it at this location. So, yeah. Okay, so the big problem with this, of course, is what if only half my resources I only got half my resources before there was an error. I have to only tear down what I've got. That's what this pattern does for you, okay? I'm going to warn you in advance. I'm going to give you two versions of this because the first one, the one that is idiomatic C, involves go-tos. So a great many of you are already starting to get a little upset because there's a go-to around here. Oh my God. Okay, so I will show you the idiomatic version, and then I will show you how to do it that will pass any coding standards on the planet, okay? So basically, I'm just going to show you the pattern. It's easier. So here's how this works. I'm going to say if there's an error in acquiring resource 1, it's a little bit of a pseudocode-y thing. And I had to crunch it up. Trust me, none of the code in the repo actually looks horrible like this. I'm going to go to exit. I have a label down here. I didn't show it because I'm trying to save space, but this probably just returns an error code, doesn't it? Okay, that's probably all I need to do. There's nothing to tear down because why? Because this is the first thing I tried to get, and because since there was an error, there isn't anything to release because I was promised that no one's going to change program state if there's an error, right? So I can use that fact. Now, if there's an error getting the second thing, well, I do have to release the first one because in order to get here, obviously, I have the first resource. So I'm going to jump to a label which I've called free R1. It probably should be something more explicit, but this is just the sketch, the skeleton. So I free that and then I go. Now, if this succeeds, of course, then I do my work, I do the commit, then I free resource 2, then I free resource 1, and I exit. So in all cases, this actually does what we want. Now, let's do the Dijkstra version. Some of you know why I said the Dijkstra version. There were some very famous arguments about goto considered harmful. God bless him, he was an irascible old man. So what do you do if your coding standards don't allow goto? Your coworkers, thank you, Dilbert, are getting out torches and pitchforks because you put a goto in the code base. Semantically, this structure is absolutely equivalent to nested ifs, okay? So you can actually just write the nested ifs, and it's actually easy to understand, it's just harder to explain. So again, I'll show you the pattern, okay? So, LibreOffice desperately wants to capitalize this thing. How am I doing on time? I'm going to maybe squeak in. So what I do is, hey, if there's no error getting the resource, I'll try again. If there's no error getting this one, all right, I do my computation, I commit my results, I free resource 2, I end the block, I free resource 1, I end the block, and then I exit, right? So the point is that let's say I fail on number 2, that means I don't execute either the computation or freeing resource 2. I'm guaranteed there's nothing because of the whole no error or no state change if there's an error, right? So I only free resource 1. The point is this works the same way. Now, why would you use the nested if structure? Well, you might have coding standards at work. Your coworkers might kill you, okay? You might have auditors that belong to the religion of Dijkstra, okay? The ghost of Dijkstra might be haunting you in your dreams because this is such a strong religion, okay? In any event, why would you not use it then? The problem with this is that it actually does not serve what it's supposed to serve, which is making it easier to read. Why? The if blocks tend to get long enough so that you don't follow by eye what the indentation is supposed to do for you. Even worse, you also have to maintain these blocks, and your code may be smashed against the right-hand margin. And if you're like me and you belong to the religion of 80 columns, it's even worse. You know, if you like in your Visual Studio, it's 150 columns. Maybe you don't care as much. But here's the more important one that people don't think about. Suppose I make a trivial patch. I change one line in the work section, but I do have to either remove or add another resource. What does the diff look like when somebody has to review that patch? It's the entire freaking function because I changed the white space. That's not nice, okay? So you might not do it because of that. If it makes you feel any better, I'll quote a different famous computer scientist. This is what Don Knuth called the tame goto. And if you have auditors, there's an outside chance that maybe if you work in the automotive industry, they're using the Misra standards, which are very conservative because their purpose is to say, in court, we are not responsible for whatever happened to your car because we used the best practice in the industry for the firmware that now drives your car for you, or at least does some of it. And Misra will now permit that structure. They used to say no goto. Now they say no backwards goto, which is actually a pretty smart position. If you need to use the nested if, which frankly there's a pretty good chance you do because of all the reasons that I mentioned, there's a best way to do it. The best way to do it is probably going to be pulling out that work section into an inner function which is allowed to assume it has all the resources passed in, because now that one-line change actually looks like a one-line change. The outer function, all it does is handle the resource allocation and deallocation. You're not going to change it that much, so it's fine. If your standards also say you can only have three layers deep of control structures or something like that, you can actually have, God help you, you can have an inner and an outer allocation reading. The point is you can do this, no matter what the rules are. What's the benefit here? It's actually much easier to read because pretty soon you just read this. As long as your team only does it exactly that way, it's very quick. Okay, and so it's much less error prone, all right? And it's easy to keep commit and rollback semantics. And there is a free bonus. You don't know it yet, but you're halfway to understanding exceptions in C++, which is quite hard. It's easier to learn it here. I'm not going to explain that statement, but you can track it down. Okay, I'm about done here. What does it look like when I run this? The actual code does several sort of simulations. this is the case where it tried to allocate 4 resources, it only got 2, so it tells you, hey, I acquired resource 1, I got number 2, I couldn't get 3, so I now release these 2, the correct ones in the correct order, because it just works. And I do that I implement and do that with both versions of it, so whether or not you use the nested if or you use the goto, you have a template, you have an example to look at. Okay, and if you look at Valgrind, everything got freed. Why? Because we did it right, and it's fairly easy to maintain. Okay, so the last thing I'm going to say. The idea of strong exception safety, nobody actually pays attention, but it's useful not in collected languages. Not for memory. But if you ever have a design that you cannot avoid passing around resources all over the place, maybe whether they're database handles or network sockets, you can track any resource that way with the ownership model, and you can handle them like this systematically. So, and with that, the only final thought is C is a malleable language. Okay? It is fairly safe. It is perfectly normal to tell it to do things it wasn't originally designed to do. Okay? The actual really dangerous things in C are there by design, and they're not going away. So I'm sorry to tell you that. And the other thing is, C is difficult, but it's not as difficult as people have come to think. I find it quite fun. I hope it seems a little friendly under the scary mask. And since I didn't talk about undefined behavior, I didn't tell you about the scary stuff. And with that, we're done. All right. And I'll entertain questions till I get thrown out. Or I think you were first.
All right. So a lot of the sort of best practices that you covered seem as though they can be streamlined, acted using the preprocessor. Do you do that in practice, or is that too opaque? Yeah,
Well,
defer?
Can you write defer? I'm not sure if you can write defer, because defer, I actually think that what it does under the hood is implements exactly that, which means it's putting code far away from where you said defer. So I kind of suspect that you might not get defer. I won't swear it, but I'm pretty sure if you do, it will be astonishingly ugly. However, even though the preprocessor is stupid as can be, there are some tricks you can do with it. I won't absolutely swear you can't do that. Here's the problem. The general problem with preprocessor tricks is the C preprocessor knows very well, now it knows something about C. It's not syntactic macros like you would get in in Lisp or its descendants. And so it's really stupid. So most of those things, to be honest with you, I'm not convinced it's worth automating them. Although it did occur to me as I was writing this that you might be able to write a usable macro so that I can notate when I am passing ownership to a function, where I would do something like C++'s move, and I would automatically null the pointer as it gets passed in. That might work. Very quickly, there's a trick about macros. Their semantics are horrible. There's one thing you can do to make it better. Put the entire body of the macro inside a do while false, do while 0 trick. If that doesn't make any sense to you, that's because it shouldn't make any sense. It's a C trick to get the macro to have the semantics of a statement. But then you can't return anything. So I'm skeptical that it's a good idea, but I await eagerly your talk next year showing me how to do it. Yes? Yes, okay. So let's go back. The question is, can we go back to the slide go-to statements? Something I can actually do. All right, here we go. We all did.
If I understand this correctly, if we have an error 2, we're going to free resource 2, and then it's going to fall through and free resource 1 and the next.
No, we're not. We're not going to free resource 2 for 2 reasons. Well, we're not going to free it because remember the idea that you don't make state changes if there's a failure? Since we were unable to, there was an error in allocating resource 2, there's nothing to free because that'd be a state change.
Say we had an error 3,
Yes.
and then we would 3 error 2, then error 1. We're going to go through
Yes.
the labels one after another because they're in order.
They'll fall through. They'll fall through. The goal here is to be able to start at any point in the reverse order and finish it. And so that's why, and then it's nice to enable these things with what the actual resource is or something like that. You need them in reverse. Everybody know why it's in reverse order? In general, one resource might depend on the others. So you'd probably better do that. Yes. Yeah. To be honest with you, good programmers in any language would do that instinctively without even thinking about why they're doing it, I would say. Yeah.
Is there a way to sort of compose that in a separate function, or to create separate functions and compose them together so you know?
Okay, you could, at any point, since this is a purely nested structure, you could put an inner level of nesting, I was hinting at that, into a different function. You would do that if you have 10 resources and you're only allowed to have 3 levels deep of a control structure, right? That's just, you just have to do that. So yes, you can do that. The problem is you have to weigh whether that makes it easier than the extra cost of going back and forth between the functions. It's a judgment call. If you do that, the first thing to break out is the work section. So you've that one is a natural separation. Put the inside, the guts away from the allocation. That's the way I would do it. If you are not allowed to do it the idiomatic way, that's almost certainly going to be the most readable way to do it. You have another question? I thought I saw a hand. Oh, I slayed them. Yes. Create monads? Well, it's bad practice because it's probably impossible. That's fairly bad. It's actually bad practice to attempt to do things that are known to be impossible because you'll get halfway there and get errors that don't make sense. So what I mean by that, I invite you to think about it because there might be a way, but it will break the type system absolutely. So the problem, I don't really know monads, but I remember looking at this once, and the problem is that C has a very old-fashioned, very simplistic static type system. I don't think this type system is strong enough to allow you to get the monad semantics. So I think you cannot have type-safe monads because you need algebraic types to do this. You might be able to do it by using, there is an all-purpose hole in the type system in C. Actually, there are several. But one among the many holes in the type system, there's something called void star, which is a pointer to anything. And you might be able to get monads that way. The problem is then you need to know what to cast it back to. And the types the compiler will, number one, not tell you if you get it wrong. And number two, it's allowed to do anything because your program is not valid C anymore if you cast it the wrong thing. Maybe. But it's kind of a scary thing. The type system is not strong enough for monads. The reason, part of that, I suspect, part of the motivation for the advanced type systems of things like Haskell is so that you can have type-safe monads. Just a guess. Okay? Generally speaking, the other thing about C is monads are kind of magical. C does not respond well to attempts at magic. C is best used. That's the part where you don't try to change it. It wants to be explicit. If it's hard, it should look hard. So the